This video concerns the puzzle which was named the Helmet Visor and which was published August 13th of 2024. And this intermediate puzzle consists of a blue quarter circle together with a gray semicircle, and there are several line segments, 3 right angles, and this line segment is tangent to the gray semicircle. And the question is the proportion of the areas of the semi to the quarter circle. Well, what you can see, well first I'll make visible the points of interest. Basically it boils down to finding the proportion of the radii of the of both circle parts, and to do that, what you can first, if I look, I can find 2 very obvious circles. If you look here, there's a right angle, and here there's a right angle, which means that over here we have a cyclic quadrilateral. So let me draw that, the corresponding circle. Yeah, this circle contains this quadrilateral. And in exactly the same way, we have here a right angle and here, so these 4 points are also on a circle. And we can use those circles if we say that over here we have the angle x. Sorry, that's let me see. Okay, I'll have to draw two chords to make the angle absolutely. This chord and this chord. Then the angle x is over here, and the angle x by using the small circle is also over here. In the same fashion, we find the angle y over here, and we find it again using this larger circle over here. And why is this handy? Well, you see here this triangle within the quarter circle. We know in a quarter circle that this angle is always 135. So that means that the sum of x and y is 45 degrees. Yeah, that's from the quarter circle. So let me put that. X plus y is 45. But if we look at those 2 other x and y angles, we see it is in a rectangle, and it's also in, we can find this quadrilateral, so that we can find this angle over here, and it's very easy to do some angle chasing, that over here we again have an angle of 135. Yeah, so let me mark that. This angle is 135. Yes, we find that by using x plus y is 45. But that implies, if I draw 2 radii to the semicircle center like this, if we have here 135, then it is very easy to find that here we have a right angle. So again, we have here a quarter circle, but then with the smaller radius, so with the radius of the semicircle. But now we're almost there, because over here we have, okay, this is very easy. This diagonal of the rectangle, of course, is the same as this diagonal, and the latter diagonal is exactly the r of the quarter circle. So here we have the r. Let's name the quarter circle as, let's say it has r because, or let's say capital R, because it is a bit larger. And here we have the radius of the semicircle with a small r. Then we know from this a half square basically. Yeah, we've just arrived that this is a right angle, so it's in the right isosceles. We know that small r is square root 2. This large r is square root 2 of the small r. So let me put that here. So the large r is r times the square root of 2. So here we have found the proportions of the two radii, and now it's very easy. You can see that this small quarter circle must have area which is 1/2 of the large quarter circle. Well, of course the semicircle consists of 2 quarter circles, so we've just arrived at the result that the semicircle and the quarter circle have the same area, so their proportion is 1 to 1.